All right, so check your answers from last night. Hopefully these are all right. Okay. Just remember, this is just negative square root of -1 times the square root of 121. Okay, break up all these negative square roots into I and something else. Okay. Check your answers for these ones. If you have a question you want to answer, just write it down. When I come back, we can talk about it. Okay, last three, check these. All right, so review questions. This is kind of stuff that's going to be on the final, so it's good to get it in early. So we want to solve for x, and to do that, we got to do a little magic. Over here, we get rid of this 5, divide by 5, so x plus 1 squared is equal to 120 divided by 5. Which is 24. Okay. Then you got to square root it. So you get x plus 1 is equal to the square root of 24. We can't simplify this. You can go by 2, 12, all that stuff, or you can just recognize that this is the square root of 4 times the square root of 6. We know this is 2. So x plus 1 is equal to 2 square root 6. Okay, technically, it's plus or minus, but important thing is the 2 root 6. To get rid of the 1, subtract it, so x will be negative 1, plus or minus, oopsie, 2 root 6. Okay, I'm hoping no one got A, because that's weird. Let's take a look at 2. We need to get rid of the square, so you square root both sides. You get x as the square root of negative 40. We know that this is really square root of negative 1 times square root of 40. Which this is really Square root of 4 times the square root of 10. This guy's really I. This guy's really 2. And we can't simplify square root of 10. So your answer would just be 2I root 10. And technically this is plus or minus. When you square root something, it's plus or minus, but the important thing is the numbers there, 2I root 10. Alright, so we're going to do some weird things with I. If we did I times I, okay, that would really be square root of -1 times square root of -1. Okay? Doing some weird things with I. So eventually we might get up to like I to the 76th power, something like that. Alright? Weird things. But really it's just 4 different things you can have with I. So make sure you guys have your day 5 notes. We're doing certain operations with our complex numbers. Remember, complex number is a real part and an imaginary part. So there's a number and then something with I. So I times I is really -1 times -1. When you do that, you get -1. Sorry, the square root of -1 times the square root of -1. That gives you -1. So we know that I to the first power is really just I, and that's going to be the square root of -1. We know that I squared is I times I, which we just found out. That's going to be just plain old -1. I cubed, let's split this up, we know is I squared times I, which is -1 times I. So I cubed is just -I. And lastly, I to the 4th is really I squared times I squared, which is -1 times -1, which is just 1. Okay, so when you're dealing with I, these are the only things that they can be. Okay, I to the 5th would be square root of -1. I to the 6th, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, it just keeps going on and on and on. These are the only things that I can be. But you can be anything. Okay, so if we're doing these complex expression stuff, we're starting to multiply. You just multiply it by the number outside of the I, just like this was an X. Same thing. So -6 times 2 gives you -12. -6 times -3 gives you a positive 18i. That's about it. You can factor out a 3, but that's it. Okay, nothing really to it. So you guys in your groups do 2 and 3, real quick. so let's take a look over here. It's just FOIL. Just pretend these are x's until we get a little further down. Okay, so 1 times 2 gives you 2. 1 times negative 8i gives you negative 8i. Negative 4 times 2 gives you another negative 8i. Negative 4 times negative 8. That gives you a positive 32. Now we have I times I, which is I squared. So now let's simplify a little bit. We have 2 minus 16i plus 32. I squared, we know, is negative 1. Okay, if you left it as I squared up there, remember, I is not just x, that's a variable, it's actually a complex number. We come over here, you get 2 minus 16i minus 32. So your final answer would be 2 minus 32 is negative 30 minus 16i. Okay, generally we write the real part and then the imaginary part. If you do it the other way around, you're not wrong. It's just we generally do it this way. Okay, same thing over here at 4, or number 3. It's just FOIL. So you get 12. 4 times 2 gives you plus 8i. Negative I times 3 gives you minus 3i. Negative I minus 2i squared. Do a little simplification. You get 12 plus 5i minus 2 times negative 1. Remember, I squared is negative 1. Don't just leave it as I squared. So 12 plus 5i plus 2, 14 plus 5i. Okay? It's very similar to if this was an x, except at the very end you have to worry about squareds, cubes, stuff like that. Because I is not really a variable, it's a complex number. Okay, so we talked about normal conjugates already. That's where you, like if you have 3 over 1 minus root 2, the conjugate would be 1 plus root 2. Okay, okay, so we're just flipping the signs. For a complex conjugate, you're going to be doing the same thing, except this time instead of flipping the signs of the radicals, we're going to be flipping the signs of the complex part. Okay, so for an example, if we have 3 over 1 plus 5i, okay, our complex conjugate is going to be same thing, except you switch the signs of the complex part. Okay. Switch the signs of the complex part. Now, when you do that, what happens is the I terms cancel and you're left with a number and then I squared, which is a number. So you cancel out the i's. And to show you that, let's do something down here. Okay, you're just going to FOIL this. 3 times 3 is 9. 3 times negative 9i is minus 27i. 9 times 3 positive 27i, and then negative 81i squared. So you'll notice these are the same, it's just the sign is switched for the complex part. Okay? That's the only thing that's different. And when you go through and FOIL that, you get negative 27i and positive 27i. So these two cancel out. We know that I squared is negative 1. So this is really 9 plus 81, which is 90. Okay, complex conjugates, all they do is they cancel out the I terms, and you're left with a number down here. That's why we do it. We can have imaginary numbers up in the numerator, that's fine. But we don't want any in the denominator. So to get rid of them, we use a complex conjugate. Just like the other conjugate, just instead of 1 minus root 5, you're going to be switching the signs of the complex part. Okay, so I want you guys in your groups to try 5 and 6, I believe. Just kidding. Just fine, we'll do it right here. So let's FOIL this. We get 144. 12 times 5 is positive 60i. Negative 5 times 12 is negative 60i. And then negative 5, so we get negative 25i squared. Okay. Positive 60i, negative 60i, they cancel. Hooray! You get 144 minus 25 times negative 1 is 144 plus 25 is 169. Which is, if you don't know this, the 13 squared. It's a good one to memorize. But complex conjugates, all they do is they cancel out the I term and you're left with a number and I squared. That's it. And since we know that I squared is negative 1, it makes simplifying it much easier. Okay, so to simplify these 4 problems, you only need to worry about the complex conjugate when it's something like this. Okay? When you have a number minus I, something like that. When you have this, you don't have to worry about switching signs. Okay, I mean, you still have to get rid of the I, but you don't have to switch the signs if you don't want to. So, I'd recommend always doing the complex conjugate, but you don't have to. So, complex conjugate of 2i is going to be negative 2i. So when you do this, you get 3 plus 5i times negative 2i all over. Okay? So when you multiply these, you get 2 times negative 2 is negative 4. I times I is I squared. And up here you get negative 2 times that, so you get negative 6i. Negative 2 times 5 give you negative 10i squared. Okay? We can simplify this down here and up here. The negative 6i minus 10 times negative 1. So negative 4 times negative 1, that becomes a positive 4. This becomes a positive 10. Okay, so we've simplified this a lot. And we can still simplify. So this, you can divide all these by 2. You get 5 minus 3i over 2. That is your simplified answer. So if you didn't switch the sign originally, you would just get a negative out front of that. It'd be a little different, but it'd be the same thing. So when you have a complex number in your denominator, just use the complex conjugate. So you switch the sign of the complex part, and it gives you a nice thing like that. Okay, so to keep this up, we're going to go to number 8. Okay, we're on number 8, then I'll go to 7, then 9. So number 8, the complex conjugate is going to be 3 plus 2i. So when you do all this, you get 1 plus I, 3 plus 2i. Okay, that's just all. Let's find out. So we do this, we get 1 times 3 is 3. 1 times 2i, 2i. I times 3, I times 2i. And that's all on the top. In the bottom, we get 9 plus 6i minus 6i, then minus 4i squared. So we do a little simplification. We got 3 plus 5i plus 2 times negative 1. These guys cancel. Hooray. I like that. 9 minus 4 times negative 1. Okay, we just substituted. Canceled out all the i's we could, combined them. Substituted in negative 1 for I squared. Okay, so we do a little simplification again. You get 3 plus 5i minus 2 over 9 plus 4. And this will give you, minus 2, 1 plus 5i over 13. And we can't simplify this anymore, so there's number 8. Ah. Okay. So you guys, in your groups, do number 7 and number 9 real quick. Alright, so let's take a look. Number 7, complex conjugate of negative 3i is going to be positive 3i. When you do that, you get 5 minus 6i plus 3i. Okay, so you just FOIL it through, you get 15i minus 18i squared. On the bottom you have negative 9i squared. I squared, not nearly as good as ice cream. Okay, so we're just going to substitute in. We got negative 1. And this makes it a positive 18, so 18 plus 15i all over 9. And you can simplify this by dividing out of 3, so you would get 6 plus 5i all over 3. Okay, be mindful of your negatives. This can trip up a lot of kids. So number 9, to get rid of the I down here, we're going to use the complex conjugate, which in this case is going to be root 2 minus I. When you get that, you get 7 minus I, root 2 plus I times root 2 minus I. So let's FOIL through. We got 7 root 2 minus 7i all over. So root 2 times root 2 gives you 2. We have negative I root 2, positive I root 2, and then minus I squared. Generally, when you have square roots and i's, you want to put the I over here. Otherwise, it might look like the I is under the square root, which you don't want. So generally we put the I on the left side. So we got our top, bottom. These guys cancel, hooray. 2 minus negative 1. Really? Two plus 1, which is 3. Okay, there's your answer. You can leave it like this if you wanted. That also works. It's all the same thing. If this were 7 down here, then these would cancel, so that'd be nice. But in this case, nothing cancels, so we can't simplify anything. Okay, so if you have any questions, make sure you write them down, star something, so that we can go over them when I come back. So for your homework, it's just, this should be a lowercase I. Simplifying, okay, you're just foiling, distributing. Over here, simplifying, you have to use the complex conjugate. So complex conjugate of I is negative I. Of 3i is negative 3i. So just switch the sign of your complex part. And then a little review. Okay. Simplify it. Solve it. And just remember, Complex conjugate. Just change the opposite of the complex part, not both parts.